My name is Phillip Carter. I'm so used to like saying what my previous job was. I recently changed jobs. I am a product manager at Honeycomb. We're a startup that builds observability tooling. It's really, really cool. I don't have any material for you to check out there, but I will say that, I mean, being a startup, like we're focused on a particular vertical, but if you are in the business of writing services and you are a developer, our intention is that we're the best tool that you have for understanding what the hell is going on in your services. That being said, I'm going to talk about nothing related to Honeycomb for the rest of the night, unless you have questions at the end about that, in which case I can talk about that. Things like open telemetry, that kind of stuff. That would be a totally different talk. Instead, I'm going to talk about F# and .NET. F#, a language that I helped run at Microsoft for 5 years when I was on the .NET team. And it was really a pleasure kind of being there from the beginning of, or kind of the beginning of the cross-platformization of .NET with .NET Core, and really driving a decent part of that with F#, making our compiler cross-platform, and then just fundamentally pivoting the language to be cross-platform first rather than be like the OCaml for Windows, which is kind of what it used to be. So now I think it's gotten to the point where F# is a language that like it's vastly different from C# in terms of the way that you do stuff, but you still have access to all of .NET, so you can do really great things with it. But it's in a position where like if you're a JavaScript developer or a Python developer or a Scala developer, like you could come to F# and feel like it's probably gonna work out well for you. So I will go through a little bit about how you get started with F# in several different contexts, like starting with the command line, going to building up like a quick and dirty web service that you can talk to, a little bit of code in between there, and then I will get into F# for notebooks, which I think is a really, really fascinating take on interactive and analytical programming. I personally think that it is better than Python for a lot of tasks for that. And we all know that Python is kind of like the king of data science and data analytics right now. My hope is that F# can be like that sometime in the future. And a lot of the fundamentals for that have been built and are continually getting built up. And so I encourage you, if you're a .NET developer, but also like if you're interested in other languages that you would use for something different than like just bog standard .NET web services development or something like that, try out F# in that different context. Just try out a totally different language, doing something totally different, and have a lot of fun. So with that, let's go ahead and get started. I'm going to share my screen. And we verified that this works. And I think you should be seeing one of the screens. Hang on. Okay, share screen, you should see a terminal, is that correct?
Looks good.
Okay, cool. All right, I have the Windows terminal open. If I were on a Mac, this would be the Mac terminal. So I can type .NET. I can see that I get something from the command line. This is a prerequisite, is you need to actually go and install .NET if you don't have it. Now, if you're a .NET developer, this is not going to be a problem for you because you already have it. I have .NET 6 installed. Everything that I show you could be done with .NET 5. .NET 6 is coming out, I believe, either next week or the week after. So, you'll probably just want to use .NET 6 from this point forward. But anyways, if I go .NET new -H, blow this up a little bit. So .NET new. Typed on it new. Okay, there we go. So there are some templates here. You'll notice there's a class living console available here. You can also do a .NET new web stuff. They hide a whole lot of stuff by default because there's like a bajillion templates that are installed in your machine, but they don't want to blow up your screen there. But there are some F# options there. So what I'll do is I'll go .NET new console -lang F# -o console F#. Okay, so that's going to create it. I'm going to open that up. I'm opening this up in VS Code, and I have a couple of extensions installed. You don't have to know which one it is up front. it's inide is the name of it. But if you just open up an F# file, you'll get a notification and it'll say, we recommend the inide extension for this. And so you make sure that you have that installed. Ion IDE, so inide F# in this case. This is a community extension that has 360K installs, so it's pretty solid. It is using the F# compiler services, which Visual Studio also uses. So it's like built off of the same core stuff. So you get a really rich IDE experience. So first of all, it's a basic F# file here. I'm just gonna get rid of like some white space and stuff. Single line of code, hello from F#. You're probably gonna be able to understand what this does. I'll do .NET run, and it will run it, and it says hello from F#. That's it. That's how you do hello world. It's pretty great. It's nice and easy. But you can do a little bit more than that. So let's say you wanted to capture some command line arguments. Well, you could do, I guess, two things. There's a convention where you can create like a main function with an entry point attribute, and it captures the args and stuff like that. But a different way that I actually kind of like is I'll just actually get the args. You notice I also have a GitHub Copilot installed. It does not officially support F# yet, but it actually can work surprisingly well once you give it a few more hints. And we'll go environment.get command line args. So you notice it was actually already able to autocomplete that for me. Okay, so instead of printing hello world from F#, we'll just go, we'll do an interpolated string here. So this is an F#5 feature. And we'll go args. Okay, and we'll run this again. And we'll see, okay, system.string, that's not right. Well, that's because this is just doing a toString on an array. What you actually want is there's this format specifier that you can do in F# called %a. This is sort of like a pretty printer. And so what it'll do is that given the value, it'll pretty print the values there. And there's a whole lot of other format specifiers. And so this is really, really helpful when you're doing text processing. So again, I'll do .NET run. And in this case, it gave me one there. I will call .NET run, hello there, Greg. And I got 4 command line arguments, actually. I got the name of the DLL, and then I got hello there, Greg. So I actually do want to filter that one out. And so that's kind of a thing that you got to deal with if you want to get command line args this way. The other option is you can go let main args, and then you return 0, and then you do entry point, get rid of this, and you can get rid of system too, target. Okay, sorry, I curse a lot sometimes. And I run hello there, Greg, and there we go. It got rid of that guide for me. It just has the arguments there. So if, let's say I wanted to do something with those args and like print them out a little differently, I can just do a for loop for arg and args do. And then I'll just move this guy over here and get rid of that format specifier, do arg, call that again, and that'll print them out on a new line instead of as an array. So yeah, pretty easy, but you can do a lot more than just print out command line args in F#. So let's say I had a list of integers and I wanted to do something interesting with them. Let's say I wanted to filter out anything that was even and square the values. We'll go let is odd is x is equal to, x is equal to x mod 2 not equal to 0. So what this is going, so this is a function actually, is odd. If I hover over it, I can see that there's a function signature here. It says that x is an int, and this arrow means that it produces a bool, right? And so this expression right here is, I'm just doing a mod expression, and in F#, not equal is this sort of SQL-like thing. So instead of doing this, you do this. That's just how the syntax is. So then I want another one. I want to square the values. You also notice, by the way, that inide is printing out some type signatures. So I didn't mention this before. I was hoping you would just kind of not even really notice, but F# does not necessarily require you to annotate all of your types, right? If this were C#, maybe it would look more like this, right? Int x. Well, that's not a thing. You can actually do this you can give it an explicit type and constrain the type that way. Sometimes it's necessary depending on your circumstance, and sometimes it's recommended, like if you have like a public API and you want to really be explicit about the types for things. But otherwise, the F# compiler performs type inference at compile time, where it infers the type of what you're doing based off of your usage. So in this case, because I am modding X with 2 and I'm comparing the result with 0, X has to be an int. Otherwise, this would not like satisfy the type equation stuff that's going on inside of the compiler. So that's how it knows that X is an integer. And that's how it also knows that this comparison right here, this produces a bool. So it knows that it has to produce a bool. And that's kind of a very short overview of how type inference works. So anyways, I'm moving on. I have a way to check if a value is odd. Now I want to have a way to check if something to produce a square. So we'll go let square x is equal to x times x. Copilot was able to figure that one out for me, so that was pretty nice. But now I have a list of these things, okay? And we'll call it get odd squares. And we'll say it's values, okay? So Copilot's getting a little funky right now. I'm just going to ignore that. Copilot is still in pretty hard preview right now, so don't worry about that too much. If you don't have it installed, you don't see these little things. You just get a nice or blank editor. But I'm going to do what's called pipe this values, which is currently unused and just a generic value. I'm going to pipe it into a list processing function. So if you're familiar with Unix pipes, if you're familiar with the JavaScript pipelines, maybe, or Elixir. No, I don't think JavaScript has the pipelines yet, but lots of languages are starting to add these as well. F# has been having them for a long time. I'm going to pipe that into list.map. This is a function that maps a value to another value. I'm going to go, actually, I want to filter first. We'll go filter is odd. Okay. So in this case, I'm passing the isOdd function as a parameter to the list.filter function. Functions are first class values in F#, just across the board. So you can pass functions around and be really succinct. And then I'm going to map a square like that. Okay. So let me pull this down a little bit. Now that I have a function, we can see that on the types, it's sort of inferred here. This is an int list, this is an int list, int list. Let's say I did this. I did list.map string. Now the linter wants me to combine these two functions. So there's another way you can do this. That's a little bit more succinct. So this is basically saying I am composing the square function and the string function. So I'm going to map square onto the filtered list, and then I'm going to convert each of those values into strings. You notice on the side here that this pipeline synthesized comment here, it changed from int list to string list. So this is a feature of some F# tooling, is based off of like how type inference changes things in your code base. In the case of pipelines in particular, you can get tooling that will show that, which is really, I think, really helpful, especially if you're a beginner. But I'm not going to bother with transforming it into a string right now because we're just operating in the world of numbers. Okay, so now I have this. I have this function that I can call. I can get some values. So let's assume that the values in the string array are actually going to be numbers that I want to put into a list. So I'll go list. And I will create what's called a list expression. So programmatically creating a list based off of something. So I'll do the same thing, this for arg and args do, but instead I am going to do this. I'm going to call the int function, which then takes in this string. It can take in a string and try to produce an int. Now, if I pass in something that's not actually an int, this is going to fail at runtime, but this is a demo for a webinar. This is not production ready code, but that's fine. The point is that you can do this, which is great. And so now I'm going to run that through here. I'll get let result is get odd squares list. And we'll just print that result. So we'll go result there. Okay. So we'll go .NET run 1, 2, 3, 4, 5. And we get 1925, right? And that makes sense, right? Because I'm filtering to only the odd values. So 1, 3, and 5. And 1 squared is 1, 3 squared is 9, and 5 squared is 25. So this is a few, if you're not familiar with F#, it's covered quite a few different things here. Expanded the size of this little program to quite a few things. So just kind of as a recap, a single hello world is just like a single line of code in F#. You can run that with the .NET tool. You can do that inside of VS Code. You get a bunch of great tooling for that. You can start writing functions. Functions are what you do in F#. It's a functional programming language, so you write functions. That's just how you do stuff. You can pass functions around as arguments to other functions. You can change functions. You can get tooling that shows you what the heck the compiler is actually doing to your code. You can take things like an array and you can generate a list out of that with list expression programmatically. So like if you're coming from Python, this should actually be fairly similar. I believe Python list expressions even have somewhat similar syntax. And then you can pretty print the results. You can do, this isn't much of a pretty printing, but there's a lot that you can do there. In fact, if I were to do this %d, you'll notice I get a red squiggle. It's saying that the type int list is not compatible with the integer types. That's because %d is a format specifier for that. Same thing with %s, that's a format specifier for string. So int list and string are not the same. This is an example of the F# compiler acting as a developer tool for you. There's a lot of different cases like this. I don't know if I have quite enough time. I'll cover one little example of the compiler acting as a tool for you. So let's say we'll go type transaction. So F# is a strongly typed language. Okay. We'll go withdraw, deposit, and screw it, transfer. Withdraw, there's going to be an amount decimal, deposit of amount decimal, transfer, you guessed it, of amount, I'm not going to bother with that, of amount decimal there. This is a union type in F#. This is if you want to define something that's one thing or another thing or another thing. There is a wonderful symmetry in how you actually act on one of these union types in F#. So we'll go process transaction. Okay, so we'll go match transaction. Hang on, let me rename that really quickly. Okay, with withdraw of amount. That is not correct syntax, Copilot, but that is okay. Okay, and I could get open system right here and get access to that. Okay, so I'm doing what's called pattern matching on this union type here. But you notice I get a squiggle. It says incomplete pattern matches on this expression. For example, the value deposit may indicate a case not covered by the patterns. The F# compiler is aware of the fact that I defined this type that had these cases. And if I'm operating on one of those types, I have to account for every single one of those cases, right? So if I were to get rid of these two, it's happy because, all right, cool, I've accounted for everything. But if I'm not accounting for everything, I'm going to get a warning. Now, if I choose to ignore that warning, I'll get what's called a match failure exception at runtime. But a lot of F# developers will build with warnings as errors because they really care about this warning in particular, and they want to make it an error. This is a fantastic feature of the language that catches you all the time. Because you sort of get into this mode of you're defining your domain in terms of types, and they perhaps have relationships between each other. And then you want to process the data that you are representing with that domain in a particular way. And like that domain is going to change over time because everything changes in software. But how do you know that in all of the various places throughout a big code base, for example, that you are accounting for all of those changes? Well, gosh, it's sure nice. It sure is nice if the compiler can act as a tool to, catch you there, because then you can be a little bit more lazy about that kind of stuff and just focus on what actually matters, which is understanding the domain and understanding how you are going to process data inside that domain. That's this core feedback loop in F# development that I think a lot of people, when they get into the language, they really love doing that kind of stuff with it. So covered quite a bit there. Covered functions and values and types and that kind of stuff. There is an abundance of stuff online that, especially there's this guide called F# for Fun and Profit. That is kind of like everybody in the community. It's their favorite guide for learning how to do this kind of stuff. It's like this wonderful website that has enormous, a lot of sections where it's like a 30-part section on like learning the language, for example. And he has all these great use cases in the website there that cover just what you would use the language for in a way that's like a bit more realistic. So like not necessarily numbers based, but the concept of like a transaction or domain modeling emails or like that kind of stuff. Highly recommend that you check it out. And, of course, if you use something like Terminal, you can just new up a thing, open it up in VS Code, get cracking, and have some fun. So let me see if there is some questions, that kind of stuff. All right, no open questions so far. Feel free to leave as many as you want. I will check them regularly here. All right, so you have the command line, you have VS Code, you can do some cool stuff with that. Let's open up a different editor, one that I like to call Visual Studio. It's been around for a while. It's a little bit bigger than VS Code, takes a little while to load, but that's okay. I'm going to create a new project in here. So there's new project integration in here, first of all. So this is just the base templates, you can install others. Go all project types. So I can create like console app, library, some ASP.NET Core stuff, worker service, some test projects. F# is not for Windows GUI development. You can use it for that, but the Windows GUI stuff, it tends to be like very, very C# specific, and a lot of the UI frameworks tend to not be as nice to use from F#. There are other ways to build F# UIs, especially for the web, with a tool set called Fable. I'm not going to cover that today, but it's something we can certainly explore. Instead, I'm going to cover some more web backend stuff. So I'll create an ASP.NET Core Web API, and we'll call this F# ASP.NET Core Web API. Fancy. All right, so we're going to create this thing. I'm allowed to complain about Visual Studio being slow because I worked on it for 6 years. So Visual Studio is sometimes a little slow, but that's all right. Once it gets going, it's fine. Just needs a little, needs to warm up a little bit sometimes. All right, so if you've used Visual Studio before, you probably know exactly what this is. You got good old Solution Explorer with a bunch of stuff in there. Notice there's a bit more involved code in here. It's program.fs. This is calling some ASP.NET Core APIs. It's actually a way to simplify this. I might make a pull request to pull this down so that it's just like a single file with some of the new ASP.NET Core web APIs, but that's fine. It'll come later. So you register what they call a web application, you build it, do some stuff, blah, blah, blah. Go over to the controllers. Here's a data type, this thing called a weather forecast. This is using an F# record type. Contains a date, a temperature in Celsius, and a summary, and then a member called temperature F that it computes based off the data that's in there. If I open up a weather controller, again, if you've used ASP.NET Core, this should not be terribly surprising looking, except for the fact that it's in a totally different language than C#. But in here, there's a class definition that has some, it's inheriting from controller base. So you can do this object-oriented stuff in F# as well, because it's a .NET language, and .NET inherently has some object-oriented stuff inside of it. In F#, object-oriented programming is not what is emphasized. We like to call it object programming, and it's kind of more like a means to an end. Like sometimes classes and the features that classes have are the appropriate tool for the job, and you should use them when that is the case. But you shouldn't necessarily feel like you need to jam everything into a class, oftentimes like you do in C#. And so this is one approach that you can do web application development that uses things like attributes and classes and so forth. And in this case, there is a get route on here that is going to get the weather forecast. So if I just run this, I did Control F5 to run it. I will pull this over into the view here, and you can see this produced some JSON. All this did is it went through a bunch of weather summaries here. And then it picked 4, basically it looped from like 0 to 4. And then it constructed a weather forecast object based off of that. And what it did is it basically did it for now and then randomized what the summary is going to be. So if I were to run this a couple different times, you'll see the values can change a little bit. So that's kind of fun. So this right here, localhost / weather forecast, you can imagine in this controllers folder here, you create another controller that has, another get or perhaps a post or something like that. Critically, one thing that you do have to do in F# is you have to maintain what is called file ordering. This is to assist the type checker in understanding types when you do type inference. So if I were to create like a thing called a Greg controller or a Phillip controller, I would put them before this program.fs file. And if any of them depended on this weather.fs file, like any of the types in there, it would sit in there by default. Now, what's good in Visual Studio tooling is I can just right-click add, and I will create a new item. And I will call this Phillip controller. Okay. I would have to copy paste some stuff in there. But critically, if you move over here, you'll notice that I added it into that folder. It's in the top of the item there, and it's added in the right spot. So F# tooling integration will handle that concern for you, which is pretty great. Every once in a while in F# code, you need to move files around. Like let's say I defined a value inside of here that I want to depend on inside of Phillip controller. Well, I can go right click and I can go move up or hit the Alt up arrow key, and that will move it. And then if I go over to the FS prod, you'll see that this did the appropriate move inside of the tooling there. So Visual Studio has quite a few benefits compared to just using a text editor. Because like if you use a text editor, you're going to have to manage this stuff yourself. And most F# developers are fine doing that. But if you're the kind of person who doesn't want to have to care about that, you can use Visual Studio, just add files around, and you're probably going to have a good time. So there's a lot of features in this Visual Studio integration. So like, for example, I can check out what the controller base actually looks like in here. There's a lot because it's a big file with a bunch of stuff. But this is cracked from metadata, right? Like this is not a part of my actual source code here. I can look at iLogger. I can choose to control and click instead if I want to do that. I can find references on how many iLoggers there are in here. Looks like there's only one, so that's fine. I can take this logger, which I don't think is in use. Yeah. So I can prefix it with an underscore. I can change it to an underscore, which is way that you can go ahead and do stuff. I can rename this my fancy logger. I can go to definition to it. I can go to the summaries. I can go to definition like that. It's pretty standard Visual Studio style tooling that you would expect if you're coming from a .NET side. Now, there are less features in F# Visual Studio tooling compared to C# Visual Studio tooling, but they're not. It kind of varies from person to person how impactful that is. So some people love hitting the light bulb. Right? They see that light bulb and they want to, they live, like, especially if they're a ReSharper developer, they live to just select code, see a light bulb, hit Control dot or Alt Enter, I believe the key command is in ReSharper, and just see what all the options are for a little micro refactoring, that kind of stuff. That is not that common in F#. There are some refactorings. Most of them are error-based. A quick example of one is, let's say I have Oh, right, I'll just do this. Print fn, I'll do percent, what's system random return? Percent a, and then I'll go system dot random. This is a compile error. You may not expect why, but the reason why is because when you call an F# function, you're not calling it with parentheses on the inside. You're just doing a space and then the parameter and then a space and the parameter. And the F# compiler says, well, this might be one parameter, but these parentheses could be another one, right? There's no difference really here between these two things, and that's kind of wrong. So the compiler is a little bit confused. Well, if you just do that, you can wrap the expression in parentheses with a quick fix. And so there's a set of quick fixes like that. Like if you have lambdas and you're specifying them with the wrong syntax, which sometimes happens if you're coming from C#. The Lambda syntax is a little bit different, but it can detect that and change it for you. There's I think a few dozen of them. But like, if you're used to C# and ReSharper, you're going to get a whole lot more. So F# may feel like it's less tooling in that regards. But if you care about the basics, like syntax colorization, build tooling, solution integration, go to definition, refactor, the rename refactoring, find all references, different types of go to definition, and a handful of others as well, like standard IntelliSense, right? Like system dot, whatever. You can clearly access that kind of stuff. If I go console dot right line, you get the little signature help where you can toggle all the overloads, like that kind of stuff that you sort of use all the time, but may not necessarily be aware of the fact that you're using it, because it's just like when you're typing and doing stuff, you sort of get that assistance. All of that is pretty much available for F#. So if you're particularly bothered by not having things like ReSharper ReSharper commands, that kind of stuff, well, maybe F# isn't for you. But if you're okay with that, that's fine, because I think there's a lot of other benefits, namely, especially in larger code bases, F# ends up being a lot less code, so you need to refactor a lot less as a result. So you can also do something in F# called scripts, script files. These are great when you're exploring something, right? So I could do that same spiel with the squares and getting the odd squares and stuff like that, but you can do more than that in scripts, which I think is really, really awesome. So I can do reference, and I can do what's called a NuGet reference. So I'm going to reference a package called Suave. Suave is a web server. So you see I get IntelliSense for Suave immediately. Start web server. Default config is what I'm looking for here, and we'll go successful.ok. Hello, folks. Okay. So this is Suave APIs right here. This is a single line of code to start a web server in the Suave library. This config, oftentimes you just use default config, especially in development mode. Eventually, if you use Suave for production, you're going to have a more complex config option that you would pass in. And this only does one thing. It just says hello world. But I can select all of this, and I can hit Alt-Enter, or I can right-click and go send to interactive. I never even use it, so I can't even seem to find it. I'm just going to go Alt-Enter. So this is going to execute it over here in the F# interactive window in Visual Studio. And you'll see in the output, it says smooth, Suave listener started with this binding. So we'll go over there. And it says, hello, folks. So just 3 lines of code, and I have a web server that's talking to me, which I think is pretty cool. I'm going to reset that interactive session. As you might imagine, having an interactive session in Visual Studio with open web servers can be a little fun when you're relaunching those web servers. I'm going to paste in some code here. Well, a little bit at least. I'll write out a little bit more of that, just to show some of the interesting succinctness that you can do in F#. So I'm going to define what's called a web app. Okay. I specify what's called a choose function in Suave. Whoops. Okay. And then I want to define some get. So I have this thing called a get. Now, here's a little fancy operator. I call it the type rocket. It's called a Chrysler composition operator for those who care about being mathematically correct. You don't have to care about the mathematics of the operator, but instead I'm going to define a path here. I'll call it hello. And then I'm going to use this type rocket right here. I'm going to go, okay, hello, and get. Okay, so show you what this means. F# operator stuff. Sometimes some libraries will use operators, but that's not a whole lot. This is sort of a compositional thing. This is basically me saying that I'm constructing a path for a web server, and I want to associate that and compose it with the result. The reason why this works is because there's a compositional nature to constructing this kind of stuff in F#, where like inputs produce outputs, and web applications can be composed of several different kinds of routes and subroutes and that kind of stuff. And the particular model, the routing model chosen here, is one that uses these operators. There are other web servers available in F# that use a totally different approach that I will actually also cover. Again, actually, I should say goodbye. And the reason why I want to show some different things there is because there are different approaches in F#, and the community has chosen different ones, which I think is fascinating. So what I've done here is I have the start web server and I have this web app, and I have two paths that I've defined that are each a get operator. One says hello and one says goodbye. And I'm passing this web application, it's called a web part, into this start web server thing. So basically, you can imagine maybe there's 100 routes. Well, I would lay them all out, and then I would pass that in as a parameter, and I would get that. So I'm going to do alt enter. I'm going to send that over to F# Interactive. We'll go over here. Web page not working. That's because I need to actually specify a route. Specify hello. It says hello from get. And if I say goodbye, it says goodbye from get. So like this is a vastly different way of building web applications compared to the ASP.NET Core controller style, right? You may prefer this, you may not prefer this. The cool thing is that you can do either. Like you can pick the one that works best for your team rather than being pigeonholed into one specific way that you go off and do stuff. And I think it's also neat that you can spin up a web server in an interactive process inside of Visual Studio with like what, less than 20 lines of code inside of the script file without even saving the damn thing. It's pretty cool. So on that theme of web applications, I'm going to do one more. Okay. There's a wonderful library. So the most used library right now is a thing called Giraffe, which is actually somewhat similar to Suave, but instead of having its own web server technology, it sits on top of ASP.NET Core. There's another library called Saturn that uses Giraffe, because Giraffe is a little bit more low level, and it has like a very nice DSL that you use to do that. Rather than showing those two, because you're probably going to come across that if you interact with anybody in the F# community, I will show yet another option that is built on top of ASP.NET Core that works wonderfully well, and it's called Falco. So I'll go .NET New Falco. So what I did here, I think if I thought there was like a command to show every single one that's installed, but anyways, what I did is I did .NET New -I Falco.template. I did like this sort of thing. This is a command that you can do from the command line to install templates to your .NET CLI. I already ran that. So I have the Falco scaffolding option, and I'll just go Falco web app. Okay, so whoops. Code Falco web app. Oh, don't save. Go away. Hasn't been updated to .NET 6 yet, so I'm just going to go ahead and do that. I think it should be, oh yeah, that has to get restarted, that's my bad. Okay, I updated this to target .NET 6. I think when .NET 6 releases, Falco is going to have another update that targets .NET 6, but right now, that is what it is. I think there's like a little cache thing that needs to get messed with. Sorry about that. This is what happens when you decide to live on the bleeding edge in the middle of a demo here. Okay, cool. There we go. For some reason, so as a side note, someone who's worked on .NET tools for 6 years, the period of like a month before a major .NET release is the worst period of your life when you are a tooling developer, like the people who run the Inline plugin. There's all kinds of like, you live in this world where you have to support the older version of .NET, but you also have to support the newer version. And like, you have to load build tooling up in the IDE context, and like, it's like impossible to load up both at the same time. And so when you like change like .NET 6 versus .NET 5 at the same time, like basically the problem is a lot of people near the end of a release cycle want to try out the last previews because it's pretty stable. And so then they're going to like do weird crap like I did, like change the TFM and force that to reload a whole bunch of .NET tools into that process. And then like, it can just get kind of screwy sometimes. So sometimes you just got to close your IDE and like do that. And then like after .NET 6 releases, it's totally fine, because then like you just kill off the .NET 5 stuff and go to the .NET 6 stuff. The .NET 6 stuff builds all the previous .NET 5 stuff, so it's totally fine, and then you're good. So this is like actually the worst possible time for me to demo changing the target framework in a project file. And I want you to know that in like a month from now, if you do this kind of stuff as well, it will just work. But anyways, even then it wasn't too bad. I just built from the command line and then I reopened it and it was happy. So anyways, we're looking at some code here. This is totally different than other stuff. This is a Falco web application. So I'm opening Falco, Falco.routing, Falco.host builder, Microsoft ASP.NET builder. There's this thing called an exception handler. I'm not going to bother explaining that right now. That just it serves up some plain text if you get a 500 internal error. So an exception is thrown inside of here. There's this kind of stuff here. You can usually, I think you can usually get rid of these in production, but this is good for development mode. And then you have this thing called endpoints. And so this is similar to what I was showing with Suave, where I have a get and I have a string that represents the path, and then I have a result. But this is very, very different from doing that kind of stuff. So let's write a little bit of code here. So, you know, this is pretty straightforward. Slash just says hello world. Falco has this concept of handlers. They're literally called HTTP handlers. So basically, like this thing right here, this response of plain text, this whole thing is like an HTTP handler that is going to be associated with this route. And if you want to do anything interesting, like pull a value from a route or pull a value from a query string, you need to write a handler that is going to actually process that information and then do something with it. So I'll write both of them here, right? So we'll call this the name handler and give that a type of HTTP handler. Okay, so this is clearly the wrong code that was completed for me, but that's totally fine. I'll go let get message, and that is going to take a route, and that is a route collection reader. That's the name of the type. There's documentation for this. So like if you wanted to look up how to do this on your own, you go to the Falco homepage, just type F# Falco, and it has examples in here that do that. And I want to get the name for the route, name from route, right? So I can do this thing called route.getString, and I'm looking for a substring in the route, at least at the very end, called name. And there's also a default value that I might have. So I'm just going to say that by default, it's going to say world. And then I am going to get the full message from that. And that is just going to say, hello, name from route. Okay. And then I'm going to do this thing called request.mapRoute. And I'm mapping, so this takes in a function. I'm gonna pass in that handler function that I had, a little mini handler function right there. Response.of plain text. Okay, so this is all happy. This name handler, this has an inner function that is going to extract out a substring from the route. It's gonna create a string like that, and then I'm gonna map to what's called a map route, make it plain text and do that. So now I wanna just wire this up. So we'll go get, and I believe this should say name. Damn it, it was not that. That's okay though, because I'll go straight to the docs. Come on, here we go, here we go. It's very, very easy. I swear, like there we go. Okay. We'll do a /hello and then slash. This uses the ASP.NET Core string route thingy stuff. And then I'm going to pass name handler here. So what this is doing, this is an ASP.NET Core concept. This is saying that I have a route called hello, and then there's a value at the end of that is going to be the name. And it's an alphabetic alphabet thing. I think that's what is alphanumeric or is alphabetical. I don't know. It's one of those two. But anyways, then you pass in this name handler, this person that I have right here. So if I were to run that, so one, okay, that is going to run on localhost 501. So that says hello world. And if I go /hello, that's not going to work. If I go hello Bob, I get hello Bob. So this is pretty much working exactly as I would expect it to. And go hello Philip. That extracted the route there. You can also wire up a query string handler. Okay, so again, it's totally different. But in this case, instead of getting the route, I'm going to look at the query, this query collection reader, and I'm going to extract a name from that there. And in that case, I should be able to just do hello like that, and we'll go. Did I call it? Oh, did I call it name? Query name handler. That's it. Yeah, there we go. Okay. Go .NET run. Should probably use .NET watch run. Okay, and we'll go hello. There we go. Name is equal to Philip. Name is Greg. Name is F#. So this is just executing this route right here, and it's calling this name handler, which is then extracting the name from it's calling this one the query name handler. It's extracting the name from the query. Otherwise, it'll default to world if there isn't one. And then we're good to go. So that's like several different ways that you can do web stuff in F#. From there, it's, like if you use something like Falco, it uses ASP.NET Core APIs. So if you want to look up how to do stuff or work with ASP.NET Core concepts, you can do that. Your examples are going to be in C#. And most of the examples and documentation for ASP.NET Core tend to be using like the object-oriented stuff, which is why a lot of people do go ultimately to like this controller-based thing, just because the code tends to be similar. But there's a growing number of F# developers who are moving away from this and doing F# specific stuff, like with Falco or Giraffe. or Suave or something like that. So I would say that if you wanted to adopt this kind of stuff for your next service, you're probably going to be pretty well supported from a community standpoint in terms of like finding samples and like people who know what the hell you do in certain circumstances. Some of the libraries like Giraffe are actually very well documented. So if you were to look up F# Giraffe here, it's got almost 2K stars, so that's pretty solid. This documentation.md file, and it's enormous. It's got a big table of contents. It's got all kinds of like different concepts there, all the different ways that you can route. Falco also has, a plenty decent sized documentation page. It allows you to like serve up HTML and like that kind of stuff. If you want to go to Saturn F#, this is the other one that I mentioned right here. This is a different kind of framework. And like, if you wanted to go to the documentation here and start up a, on this one, there's like the get start now. I think that's it. Yeah, you install the template, you learn about Hello World, you do a bit of a deep dive. You can combine it with some other technologies. So like there's quite a few options there. A lot of F# developers are doing web programming. You're pretty well supported when you're doing that. So I think it's a great avenue if you want to introduce it into your workplace in a way that will work with everything else, right? Because if something can talk HTTP, it can talk to the rest of your system. So cool. That is some web stuff that I wanted to cover. There's a lot that I've covered so far. So like, if you feel like there's too much going on, that's fine. I'm happy to continue to take questions if you got them. And there's a lot of stuff that you can just Google. So this isn't terribly difficult. I will also throw up some code like on GitHubs and like put up a link there so that you can take a look at it if you want to see a sample there. Okay, so I want to cover one last thing, which I am actually the biggest fan of. All right, so we'll call this F# notebooks.ipynb. All right, so if you've done any Python development, you've probably done Python ipynb Jupyter notebooks, or they're sometimes called Python notebooks. I have a couple of extensions installed. The main one is this thing called .NET Interactive Notebooks. Still in preview, but like it's like you could totally use this. Like this thing is pretty rock solid. Like they're being pedantic as hell by calling it preview. But anyways, you install this puppy and you can do data science, machine learning notebooks, visualization, blah, blah, blah. You create an IPYNB. You need to select a kernel. There's a lot of different kernels available because IPYNB is a language agnostic framework for doing interactive programming. Or sorry, not framework, developer tool. So I'll just select F#. Should be it there. F# interactive. And let's just double check that it's all working. X is 12. I'm gonna, critically, I'm executing not with a Python kernel, but with the .NET Interactive kernel. And we'll see, okay, it produced the value 12. So this is clearly working. Again, I can do this printfn stuff that I was doing before. That's handy. It has a few differences in what it can display though. So this is me generating a list from 1 to 10, and you notice it generated a table with indexes and values. This is a different kind of visualization because interactive notebooks are about interactivity and a much bigger focus on visualization than anything else. So if you are doing any kind of data exploration, you want to have that capability. So to really bring that whole thing home here, I am going to load up 2 packages. So I'm doing this interactive package install here. So I'm installing this plotly.net. This is an interactive thingy. you'll see what that means pretty soon. And this thing called f-sharp.data, which is this really, really great data munging manipulation library. It has these things called f-sharp type providers, which you'll see the magic of pretty soon. Before I get into that really briefly, I will show you that you can do things like you can open plotly.net. Okay, and so now I can do something like this. Chart.line, so I get a little bit of IntelliSense there, is 1 to 10. Is that it? Oh shit, why did I forget how to do chart.line? Plotly.net chart line. Ba-ba-da-ba-da. You have chart.scatter, some line plot modes. For some reason, I totally had a brain fart here on the API call that you do there, but as you can see, there's plenty of options here. Chart.line is a pretty basic one, so I'm not going to bother going with that. So anyways, as you can tell, I haven't given a talk in a while, but this is okay. I am going to copy paste just a little bit of code here and show you what this all is. So there's a few things going on. I'm opening plotly.net as a namespace. I'm opening this thing called trace and style param. These are namespaces that come from plotly.net, and I'm opening up f-sharp.data. I'm creating a thing that I'm calling Nebraska. This is a type alias, and I'm instantiating what's called a type provider, and I'm passing it in a piece of data. This is just a CSV file. This has some stuff in it. This stuff is actually coming from this documentation for Plotly's Python stuff. So if you scroll up to the top, it's called continuous error bands in Python. There's some stuff in the great state of Nebraska that they are grabbing the data from, and then they're drawing some stuff, and they generated this graph, which is a measurement of wind speed in meters per second over time. And so there's like an upper bound, a lower bound, and a measurement. And so the question is it like, this is I wouldn't call this the most advanced graph in the world, but this is a fairly advanced visualization here. Like there was a pretty decent amount of Python code went into it. And like Python is known for being good at this kind of stuff. So the question is like, can you reasonably do this in F#? Well, the answer is most definitely yes. And I will show you how you can do that. Plotly has, sorry, not Plotly, Python has the Pandas library, which is this super, super popular thing for reading data, oftentimes in, well, it's tabular data, but like usually it comes in a CSV. And you can do a lot of magic stuff with it. Well, F# has its own magic called type providers. In this case, I have a CSV provider. So what this does is this is going to actually literally read this file, the CSV file, and it's going to generate types based off of the data that it has read. So it's going to parse the CSV file, and it's going to look at all the things that are like strings and numeric and that kind of stuff. And it's going to generate a model, and it's going to pass that typed model of what that CSV file is to the compiler so that you can get information about it at compile time and critically at editing time, which I think is pretty radical. And so when you're in development mode, you do this thing called get sample. There are other APIs available that you can do where you can like load, where like you might have like a schema file and then you have the actual data source, and you want like your build to be based off of the schema, but you want the data source to like be loaded differently because maybe it's a massive file and you want to load it in chunks, asynchronously, all that kind of stuff. But anyways, in development mode, especially when you're doing interactive stuff, this is a fantastic way to do it. This will just extract a sample from the data set. So if we wanted to recreate this guy right here, we know we're going to need X and Y values. These are clearly, you know, some plots on a point there. But then we're also going to need to define what is an upper bound and a lower bound for those X and Y values. So X and Y values are the measurements, but then, yeah, we got to do that. So how do you do that? Well, in this code, there is some values right here, time. So it's time series data, and then a sampled average. Those are the measurements. But then these measurements have standard deviation. So the upper bound is going to be the standard deviation added to that average. And then the lower bound is going to be the standard, that average subtracting the standard deviation. There's a lot going on in just these small lines of Python code. So you can recreate this in F# and it's actually pretty cool. So I don't like to plot inline. Like I don't like to define the data inline like this. I like to pull out these values, X, Y, upper bound and lower bound, that kind of stuff. And so this is how I do it. So I'm going to first get a collection, a list representation of the X values. So I'll go for row in data.rows. You'll notice that this rows thing, this is IntelliSense that came from the typewriter there. I'm gonna go row dot, and you notice I get this thing, 10-minute sampled average, standard dev, blah, 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 time. The reason why time is there is because if I blow this up right here, there's this column called time inside of the CSV. I don't have something defined in the code here that says that time came from here. This was generated from the data, which is pretty magical. So now I have a list of date times. So this isn't just a string called time. These are like actually strongly typed representations of this kind of stuff. Okay. So for some reason, Copilot thought speed would be helpful there. That's fine. It doesn't need to do that. I'm going to do this 10-minute sampled average. Okay. So that should match up with the Python Y values that we got there that represent the measurement. So I'm going to go let Y upper. Okay, Copilot was able to mostly get that. It actually, this 10 min sampled std dev, that's not actually correct. It's just called std dev. But that's okay. It got most of the boilerplate done. So in this case, I'm generating another list for a row in data.rows. I'm taking that 10-minute sampled average and I'm adding the standard deviation to it. And I want to generate the lower bound. Copilot is just going to autocomplete that because now it has, the AI has enough context to know what the hell I'm doing. And I want to generate a chart for that. This is actually a range chart. And I'll go X, Y, Y upper, Y lower. And I'm going to hit Shift Enter. Okay, this actually looks a little bit like the Python one. If you squint, go here, okay. I think I just need to make this a little smaller there temporarily. Okay, so you can kind of see there that this is sort of similar, but like, the colors are not quite the same and like that kind of stuff. So I'm not going to bore you with getting all that stuff right. Instead, I'll just copy paste some data here. So I'm doing basically the same thing. I'm calling this API chart.range, and this is coming from plotly.net, which is the same Plotly that Python stuff is using. X, Y, Y upper, Y lower, and some customization stuff and changing the axis and there we go. So this is what it looks like. So this should look pretty damn similar to Python stuff. I go like that. You know, the background is, maybe there's a way to like change the background to be light blue or something, but more or less recreated the Python one in what, I guess if I count the namespace of the white space, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 lines of code. This is fantastic if you are in the data exploration business and you're futzing around with information, you're playing around with that all the time. You're not necessarily doing production work, but you want to get instantaneous feedback on things. I love using notebooks for this kind of stuff. Even though in my current day job, I don't work on F# anymore, I actually do use F# for some of my stuff, like at Honeycomb. We released a public API for our, we have a query engine that you can query stuff, your production data, and get data from it. So we have an API called the Query Data API, where you can give us a query and then pass that some information about it, and then we give you, we pass that information back to you. You get just like the raw time series data and some metadata about it. Well, I wanted to explore some query data, and so I just loaded the damn thing up inside of a notebook just like this. I didn't use type providers. I used a couple different other ways to extract the data and play around with it a little bit more. But then I was generating charts. I generated a chart that recreated the Honeycomb UI in a rather crappy way. You know, we have this thing where like we generate tabular data, but I found that sometimes I prefer like a bar chart for that kind of stuff. And so I would generate a bar chart. I was able to generate some statistical stuff too, like box plots for events, and look at, like, you know, sort of on average, what's the distribution of events over a span of time that gets sent to us from different teams. Maybe that would be useful someday, maybe it wouldn't, but like the point is that you can do that, and it was super succinct and convenient for me to do that. And everything from like the environment to pulling in packages just ad hoc to do what I need, to manipulating the data and getting some tooling help. Like, you know, I was cursing at Copilot here and there a little bit, but like, it's pretty neat that like I can hook up developer tooling that writes some code for me and like usually gets it right, or like at least 50% of the time. That's really productive, I think. And so I love using F# for that kind of stuff. So last but not least, I don't really have a demo here because I think these docs just cover things perfectly well. If you're already an F# developer, you need to go here. What's new in F#6? F#6 is the next version of the language that is shipping in about 2 weeks. I worked on a lot of this stuff, and I'm very happy to see it get released. There are some fantastic new features coming to the language. First one is if you do asynchronous programming in F#, if you've ever done that before, and you've interacted with .NET, well, .NET uses a different kind of asynchronous model called the task-based asynchronous programming model. And F# async and .NET async, you would have to explicitly convert between the two with like this stuff called async.await task, async.start as task. It was annoying. In F#6, there is a task package, or not package, sorry, it's part of the core library. It's a task comprehension, where instead of needing to call something async and then pass it to like explicitly await a task or explicitly start a task, it's just kind of built into the language. If you're new to F#, this is a bit more of an advanced part of the language, getting into asynchronous processing of code and stuff like that. But what's great is you can just do stuff with this thing called task, and you're not going to have to like deal with a bunch of boilerplate anymore, which is pretty great. We changed some indexing syntax. This is kind of more to help beginners. Most languages, if you want to index into something, you do this. You have an expression, and you just have like the little block, and this is the index. Prior to F#6, you needed to put a dot right there in between EXPR and the brackets. That still works today, but we were able to figure out a way to make it so that's not necessary. And so that's now a nice thing there. There's some performance stuff here. .NET has reference types and structs, and you can represent some stuff with structs in F# to make it better for performance stuff. This overload custom operations and computation expressions, it's a whole lot of words that mean that if you're in the business of writing a DSL like this, you can do it more conveniently. So this is more for library authors, but like you can expect that of the library ecosystem in F#, it gets more expressive over time because of that. As patterns, there's just more pattern matching stuff that you can do. Indentation, syntax revisions, which is pretty great. There's some examples where you might get a warning from the compiler that you won't get anymore. There's this wonderful thing called additional implicit conversions. This is something that has been annoying in F#. F# is a very explicit language where, like, let's say you are working with something that expects an interface type. and you have a class that implements that interface. Well, you cannot pass in an instance of that class to the thing that says, hey, this is the interface by default. You would need to explicitly do what's called a static cast, which is a compile time thing. So it's not like compiler unsafe. But you would basically have to say explicitly, hey, this class that implements this interface is being represented as this interface at this point in time. That was kind of annoying. You don't have to do that anymore. Now, if we know that the class implements the thing and you just want to pass that in, you can just pass it in and you're good to go. And so there's a lot of little places, especially when you're interoperating with .NET source code, .NET libraries, where that becomes really helpful because it's just less code you have to deal with. There's some integer conversions as well that are made implicit now. Again, basically this notion of like an int 32 is also an int 64. And so if you're working with something that requires an int 64, you can pass an int 32 into it without having to explicitly convert between the two. You cannot do the inverse though. An int 64 is not necessarily an int 32. And so like there's some restrictions there, but like if you know that you're working with something that is going to work all the time, the compiler is going to respect that, which is pretty great. There's some more implicit conversion stuff there, which is pretty great. There's some smaller features. There's a big performance feature here. This is again more for library authors, this thing called Inline if Lambda. Helpful for numerical processing stuff in particular. Resumable code is a very, very advanced feature, but this is how the task comprehension is actually built. This is like not only for library authors, but like for very, very, very advanced library authors who care about fine-grained performance details of things that they're building. There's some additional collection functions, which is pretty great. Numeric types with unit annotations. There's this entire feature called units of measure in F#, which you'll just have to look up, but it allows you to, let's say you have an integer or a float that has meaning, like a particular measurement, like meters per second or something like that. We can construct a type that represents that meters per second, and then you work in terms of that type. So if you just pass in like the number 2, that's going to be a compile time error, even though it's still ultimately a float. It's sort of like this thing that's synthesized at compile time that says, hey, well, this 2 actually means meters per second. And so you need to say that it is a thing that means meters per second. It's a safety feature. And there's some small warning level deprecations going on there. So this whole lot here, this is just like a document, but it was just published. So there's chances are you've never seen this before. Highly recommend that you get .NET 6. Especially because it's coming out of preview either next week or the week after. I don't know the exact date, but it's very, very soon. I know that the last commit to the code base was like 8 days ago. So, and they completely cut it off. So there's some new goodies coming in F#6. So a whole lot of other existing stuff. What wasn't really talked about a whole lot here is on the tooling side. There's been a lot of new features added over the past year and a whole lot of performance work done in tooling. So like if you're in Visual Studio and if you have like 100 projects in this solution, that used to be a problem a couple of years ago. But now it's pretty much not anymore. One of the most exciting projects that I worked on was to make the F# compiler what's called free threaded, which is a way to basically, so like before there was this complex thing where like if you had all these different operations happening in Visual Studio, like go type check this file, but also I'm renaming this thing, and also I'm navigating to this file, and I'm calling F12 go to definition, and I'm hovering over this tooltip. You do it all in rapid succession. It would like serialize all of those requests in Visual Studio and process them in a queue. And like that was a way to maintain correctness, but it would also made each of those operations feel like they were slow. Like maybe if you hovered over something, you would not get a tooltip instantly when you expected it to come instantly. Well, now it all just happens basically instantly. And so I don't really have like a good demo for that because that's like you need a production code base to really see that. But if you have a large code base written in F#, you'll find that Visual Studio tooling and then also like Writer and Inline as well by extension will all behave pretty well. And like You can always push any tool to its limits, of course, but that limit is far, far further out than just a few years ago. So anyways, that's my whole spiel. I hope if you're new to F#, you learned something. It's a very different language. I didn't really want to dig into all the different syntactical differences because, like, frankly, I think it's best to just do that on your own time when you're exploring things. Advent of Code is coming up next month. There's like the best time of the year to learn a new language. I would say, like, put something on your calendar and decide, just go, hey, I'm going to try to use F# to solve these Advent of Code problems. Advent of Code. So if you're not familiar with Advent of Code, it's this really, really cool thing where a new problem is unveiled every day during the month of December. And they're all designed so that, like, you don't have to be a super expert in a language to use. It's usually just like you read in a text file and you process it and you do like a simple algorithm that has some edge cases and all that kind of stuff. F# is a great one to do that. Additionally, there's a couple of different things that you can do to, and the month of December is a special month for F#. There's the F# Advent calendar. Okay, Sergey F# Advent. It's like a special thing that we have going on here. Okay, so this is rounding out right now. You'll notice there's quite a few people who are signed up. What this does is every day there's a couple of blog posts that people in the F# community will write for this event throughout the month of December, doing interesting stuff. I'm going to be writing one in the beginning of the month, December 1st, actually, so I better get on that pretty soon. The F# Advent calendar has been going on for like 10 years or something. It's pretty wild. And there's always really just interesting things that people are doing. So of course, I would love it if you got started with F# like immediately. But if you feel like you got a lot of other stuff on your plate right now, just schedule something for the month of December, because that's when there's going to be a lot of activity and a lot of, there's going to be some really unique stuff that people are posting out here. And also, I would like to point out that Greg actually participated in this several years ago, I believe, when Azure Functions was like first unleashed upon the world and nobody really knew how to do anything with it. He had a blog post that was like, here's how you do it in F#. And it was actually kind of cool because a lot of people referred to that post for a long time. So yeah, anyways, that's what I got. So I'll just stop sharing my screen. And
awesome. Well, I think we had folks hanging out this whole time, but I didn't see any questions come through. So I think you were just blowing minds the whole time. Which basically means I'll fill a little bit of airspace here, give folks a chance, if you do have questions that you've been holding out on, you have another maybe minute or so to get those out. I would just say, even from my own experience with the language, having used it for a really long time, I echo a lot of what Philip's been saying this whole time. Like, I think one thing that gets easily lost in some of these demos, because usually, often if someone's giving a demo, they've done this enough times that they can write code. It just kind of often works first time. That's also just a feature here of F#. Like, there's one of the classic things you'll hear about the language is if it compiles, it works. And honestly, that's really true a lot of the time. So you spend a lot of your time just satisfying the compiler and getting those things to work. And then most of the time that you run the app, like, it does what you expect it to do. And then I would also plus 1,000 to type providers just in general. I remember when they were first introduced, it felt very academic. I wasn't really sure, this is going back, like 10 years, whenever those were first introduced. I didn't totally get the use case outside of, some of the data manipulation or graphing stuff that you were showing. But type providers for me are actually one of the big reasons why F# is still my go-to scripting language, because, if you think of all the boilerplate that you have to write for, creating classes for JSON responses and making HTTP calls to APIs and all sorts of, there's just a lot of cruft and boilerplate that you have to do in C#. It's easy code, it's not hard. But you could do those in like little one-liners with either the CSV type provider like you showed before, or the JSON type provider I use all the time. You could do, there's like a Swagger or Open API provider that you can create API clients without having to write any of the scaffolding for that sort of stuff. or maybe one of my favorites over the years has been some of the SQL type providers. Like some of the F# apps that I've built and maintained are probably the only ones that I've ever written SQL code on like the first try that running the app, it actually worked, because behind the scenes, it can hit your schema and actually give you compile time errors if you screw up a type or you screw up a query and stuff there. So very much encourage checking a lot of this stuff out. It's actually really powerful. And I think one of the other things that I often like to tell folks, just while I'm still filling air and soapboxing a little bit, is, and I think this is a lot better these days than the early days, but it's F#, like it's really easy as you start to get into F# to look stuff up for some of the words and concepts to get really complicated or complicated sounding. Like there's a lot of math and stuff that comes in, but you honestly don't, like that's all valuable stuff to learn. It's interesting, but you really don't need to like grasp a lot of that stuff to use the language every day. Like you don't need to understand monads and like all the intricacies of computation expressions and all these words that might, I mostly bring it up because I've seen it be off-putting to some folks or intimidating. But I would encourage you just to tinker around, play with it. It's actually like the basics are really inviting. They're very, very simple, but really, really powerful. So I always just like to throw that out there as a personal endorsement for this sort of thing. But honestly, it's my go-to scripting language for most things, just because of how powerful and succinct it really ends up being.
Yeah, totally. In fact, that's like one of the focuses of the language now. So basically, it was like this arc that we were on when I was at Microsoft of we need to fulfill the dream of cross-platform first. And with F#5 and .NET 5, we feel like we kind of got there, especially with scripting being in .NET FSI and like the package references and scripts, and that brought into now also .NET Interactive. And we're like, all right, cool. We are completely cross-platform first. Great. What's next? There's kind of like two aspects of that. The first was as .NET Interactive, the project at Microsoft was spinning up and turning into like a legitimate tool for doing stuff with .NET that was fundamentally different from what you do most things in .NET with. We were like, well, F# is perfect for scripting and interactive programming, so it should be like amazing when used in .NET Interactive. And with that comes like some focuses on some libraries and trying to empower parts of the community. So as a part of that, we worked with the community and like this plotly.net thing. Well, it's funny, it's called plotly.net. It's all written in F#, and the Plotly company actually funds it. It's an open source project, and they have someone who, they have full time working on it. But the reason why they picked F# was because the F# community were like the most interested in doing this kind of stuff on .NET. And so they're like, all right, cool. That's great. So there was a natural pull there already. And that opens up the language to people coming from definitely much different backgrounds. Like if you're coming from Python, you're going to expect tools to work in that environment. The second thing is this realization that the language it's just like a lot less code to get stuff done than C#. And like there's places in C# where something can be super succinct, and that's awesome. So it's also C# is a great language. You shouldn't feel bad for using it. But like in general, F# tends to be way less code to get a particular task done for most tasks. Python has that exact same characteristic. Like one of the reasons why people love Python, especially people who are not necessarily computer science like professionals, is because they don't have to write a whole lot of code, so they can just get some shit done. And we feel like F# has a lot of the similar attributes. And so one of the things that I worked on right before I left, and I'm really happy to see they're continuing to pick up, is focusing on like, yeah, the Python developer, but really like the whole F# is succinct. And it should be easy to do stuff in, and you should feel like you don't have to write a whole lot of code to get stuff done. And like some of that has surfaced already in F#6, like with simplifying the expression stuff, getting the task comprehension stuff, some of the implicit conversion stuff, just making it so there's less code you have to write to do things in like a few of the areas where F# could be a little bit more verbose. And like that's going to continue, of course, but like that's going to be a really big focus of the language moving forward. So I'm really, really happy to see it go that direction, especially because like for the longest time, F# kind of had a little bit of a struggling with its identity, because it's like, okay, well, but why would I use F# if I can use C# on .NET, right? Like there's all kinds of places where C# is better than F# for different things, conceivably, right? Like there's a lot more docs that are written in it. It's certainly used by more people. So like that's kind of like this weird existential thing, and like you ended up with a fantastic community of people who love the language, but the majority of programmers would be like, okay, well, I'm happy with C#, so like why would I change what I'm doing? And it's just really not compelling to tell someone who has a good language doing what they are wanted to do to change that language just because you say so. But someone like a Python developer or a Scala developer is going to have pains in their ecosystem that are not going to be represented in the .NET ecosystem, right? Like Scala, for all of its great things that it can get done, has a reputation of being too complex. And a lot of people who come from Scala and start up with F# enjoy it because they feel like the language does not emphasize the complex parts. On the Python side, you can run into scalability and robustness problems, right? So like it's easy to write a Python app that's going to fail at runtime. And like there's some tools now starting to come out in the Python world, but like they're also all off by default. So like type checkers are not available by default. And like it's going to take a long time, if ever, for the majority of the Python populace to be in a strongly typed world. And then also like, again, they're now starting to work on it finally in the Python world, but like global interpreter lock, there's like all kinds of crap that can happen in Python where like it's just not going to perform very well. And like, those are just non-problems in .NET. Like a fantastic example, actually. Let's say you are a Python developer at a Python shop and you have two different code bases that have differing versions of Pythons and different Python interpreters and differing versions of the package versions that you are like depending on inside of those things. And let's say you switch from one to the other. That is hell, actually. Because you need to set up your choice of virtual environment. It could be a PyEnv or a pipenv or an Anaconda environment, or you could Dockerize the whole thing and try to like rebuild your containers and all that kind of crap. And like, it sucks. It's really, really not fun. And this is not F#, this is just .NET. .NET just does not have that problem. You can install two SDKs side by side and you can have code bases that depend on versions of that kind of stuff. And it's all self-contained, it all just works and you don't even have to think about it. And so there are, I think, a subset of people in those other language ecosystems who they may not necessarily be drawn to C# because maybe they think it looks too much like Java and they're not interested in Java. F# is like probably a good language for them, and if they're the kinds of people who suffer the sorts of pains that .NET does better than them in that ecosystem, then hopefully we'll be able to embrace them with open arms and they'll have a good time.
Awesome. Well, I think that's a pretty perfect spot to close on. So I want to thank everyone who hung out tonight. Hopefully, if you weren't familiar with the language before, hopefully you're interested in it now. Definitely made culpa for being out here involved in this group for 3.5 years and not having covered F#, but I'm excited to have finally at least gotten the first one out of the way. We'll have to do some more for sure. But Phillip, thanks so much for coming, talking to the group, giving a lot of really awesome content and insight into everything. Really appreciate it.
Yeah, of course. And I will clean up some samples and I'll create like a GitHub repo and then I'll send it off to Greg so he can distribute it across the entire group.
Awesome. Yeah, I'll include that. Like I said, we'll have the video of this up sometime over the next couple of days. We'll post it out to Meetup and Slack and Twitter and all the normal places. So keep an eye out for it there. And for we'll hopefully have the schedule updated real soon with some sessions going forward. But in the meantime, thanks again to everyone involved. It's really exciting to do another one of these again after a few months off. Hopefully everyone's staying, safe and healthy and all that stuff. Hope to see you in person real soon. But until then, have an awesome night, folks. Take care.
Bye-bye.